area be at high beam all the time, and when there a vehicle coming or any other things where you must lower your lights. I'll play it again. It will automatically switch to low beam. What we have here is we are marking that we have seen the headlamps of a vehicle, and based on that we'll go to low beam. The basic application just does the binary thing, and the more advanced things getting out into the market this year, next year, and the following years use the fact that the headlamps become more and more complicated, and then at various areas in the world you'll be at high beam, at other you'll be at low beam. So cannot distinguish between that, the pedestrian, that box, and many other things within this very complicated scene. And pedestrian detection will work at a variety of things. Also, that's a more US area. The previous one, by the way, was in Japan, where you have the tendency of people walking on road in some of the older part of the big cities. That's a more US clip, where you'll have many people on the side, you'll drive at slightly higher velocity. But again, the thing which is very consistent is that the technology is robust. Honestly, the one thing I'm mostly proud where others have said about our technology is that lately there was a big conference at MIT where they talked about where artificial intelligence have went so far. And then one of the leading artificial intelligence researchers said, in some aspects we're not that happy with the situation, because although there is Deep Blue, which probably it's the first, probably many of you have heard, it's the first computer software which beat the world chess champion. There's Jeopardy, which did the same for Watson, sorry, which is the same for Jeopardy, and there's Mobileye, which did the same for computer vision, in the sense that it's proven that what was considered to be done by human can be done by machine vision. And as I said, pedestrian detection is one aspect. Vehicle detection is a second aspect. And again, we're overlaying the system output on the image. Of course, by the way, but that's not what a driver will see. Eventually, this information is used for either warning the driver or controlling the vehicle or doing other things. But the heart is the ability to find the object, know which of them is relevant, that's the one we mark in red here, assess the distance, the relative velocity, the time to collision with that object, analyze where there are lane marks, and use all of that information to help the driver. I'll skip that slide. One example of another technology we have is traffic sign recognition, and that's a video which was made by BMW when they have launched in 2008. The first product doing traffic sign recognition with other things in parallel, and it's done based on our camera technology jointly with navigation information for places where you don't have signs but still you need to drive at a certain velocity. It works very well, and it gives the drivers the information of what's the allowed speed limit.